This is our second video for the Transputer occam, the first one being the Hello World series. As usual, we'll be using the Try It Online occam emulator. This first URL is for the main page. The second one is specifically for occam. So if you want to review a programming language you haven't used in a long time for a job interview, then this first page is probably got just about every language you could ever use. Again, we'll be using this. All of this is in the description. You can just copy the whole description, paste it into a text file, and then you can run all the programs yourself, and you'll even have the URLs there. Okay, there's one reference book that I might mention specifically. It's the Occam 2 reference manual, and it's even online. Here's one place you can find it. You can find it several places, and I think it's a particularly good reference. Okay, we'll take a look at a occam program. Starting out at the very top, or include course.module is some mysterious include file that they have. It has lots of interesting features in it that I've found out through trial and error. So let's take a look at what some of those might be. Again, dash dash is a remark. Spaces are very important in occam. Basically, a space is like a curly bracket. So we have a process, then we indent, and that's kind of like means everything belongs to this particular process. And then later on, we can indent again. So spaces are not nothing in occam. They're actually very, very important. They kind of tell you what belongs to what. Going on, we start out with the procedure name, the channel definition. We'll be using the simplest type of channel there is, a byte, and we'll only be outputting to the virtual screen. There's an output field in this emulator, which is what we're outputting to. Okay, we'll start out with a byte definition. So these variables will have a byte type. So E, F, and G will all be of type byte. Notice that you can define several variables on one line. It's very convenient. You can also have byte vectors. So this is 7-byte str string. So you can have a string of bytes. Bytes and character strings are basically the same. Byte vectors and character strings are basically the same thing. So these 7 bytes are the vectors 0 through 6, because in occam we always start counting at 0. Occam is very big on 2's complement. The integers are 2's complement. Even the address of occam is 2's complement, if you can believe that. So you can have negative address spaces if you want. We'll define some integers, x, y, z. Now in occam, an integer is kind of an interesting thing. There are 16-bit transputers and there are 32-bit transputers. So if you have a 16-bit word, your int is going to be 16-bit. If you have a 32-bit transputer, it's going to be 32 bits. We're emulating a 32-bit transputer, so int means 32 bits. You can also specifically say you want it to be 16 or 32 bits and not flexible. So we can do that. You can even have a 64-bit int. And you can have real numbers with exponents, and you can have a 32-bit real and a 64-bit real. So that'll give you a pretty big range. So these are kind of the basic variable types. Now let's see some of the support features we have in course.module to output these various things to the screen. Remember, our channel is only byte, but these things, most of these things are not byte. So how do we deal with that? And that's what some of these functions will do. The functions we'll look at real quickly are out.bang, which is actually an inherent occam feature, out.byte, which outputs a decimal value, out.int, which outputs an integer, doesn't bother with trailing or leading zeros, out.hex, which always outputs 8 digits with a little pound sign, and out.string, so you can put out strings. So instead of having to write a little for loop for multiple variables, there's these little convenient functions, they're called, that you can call that'll do it for you. So let's see how that works. So we come down here, and remember in occam, you have to tell the program that the instructions are sequential. So kind of weird, no other language needs that. So here's our sequential instruction. Then we're going to do a whole bunch of assignments. E, F, and G are all bytes. 66, remember, is the character code for capital B. You can also put it in single quotes and just say capital C and it'll put in a 67. The compiler does that for you. You can even put in a space, which tends to be kind of a useful character. You can define strings. I just have a string called example. So let's look at an assignment, x equals 0, colon equals 0. So that's an integer. Then we're going to add 1 to it. Ooh, we're doing some arithmetic. How exciting. But we're not going to do too much arithmetic in this program. This is the largest positive number you can have for a 32-bit int. G was a byte. No, that doesn't sound right. G was a 16-bit int. So 32,767, yeah, is the largest positive number you can have in 16 bits. H, again, I used the largest positive number you can have in 32 bits. J was our 64-bit int, so there's a really big number. I don't know if it's the largest one or not. And then M and N were 32-bit real and 64-bit real, so you see these can use exponents. And you can also put in a minus sign, which adds a digit. Okay, so let's start looking at how you might output these various types of things to the screen. So again, we have bytes, byte vectors, integers of various sizes, reals, and even strings. So let's see how some of that might work. So out bang E is just outputting a byte. I usually say bang instead of exclamation point because it's a lot quicker. Now notice that when you go to the screen, E is going to be the character B, not the number 66. Then we have out bang S, which is a space. Notice that you can put the bang either right next to the output or separated. As a matter of fact, when we define it, I specifically defined it out as an output with the little bang, but you can leave that off, it doesn't matter. When you're communicating between processes, one process's output is another process's input. So after a while, you get tired of trying to say whether it's an input or output and just call it cat, dog, monkey, whatever you want. Because it's going to be, you know, one person's output is the other person's input. But the screen is kind of unique because it only goes out to the screen. You never input from the screen. You never output to the keyboard. You only get stuff from the keyboard or the input field. Okay, so now we're going to, instead of doing, we did an out E, which output a character. What if I wanted to output it as the decimal equivalent? I can do out.byte E, and then this 0 is mysterious, but it's going to the channel output port. So again, this is a function, and we're giving it the character byte E and some parameters, but this is the port we're sending it out to. This is a carriage return line fiend, out.string, star C, star N. C, I think, is carriage return, N is new line. And out F, what was F? Was our byte C, or character C. Another carriage return, and then we're going to output our string, which was example, carriage return, and then we're going to output just the string str4, which is the 5th character in the string. And remember, we made string equal to example, so we count over 0, 1, 2, 3, 4, and we get the P from string, carriage return. And we're outputting an integer, not a byte, an integer this time, but it's over a byte channel, which is why you have to do some math to get that to work. So we'll output our integer Y, carriage return. Now we're going to output an integer, but we're going to output it in hexadecimal. So we output Y here as decimal. We're outputting Y here as hexadecimal. So that should output it with a pound sign followed by 8 digits, and it will give you leading zeros. Carriage return. This is just to show a little math. We assign x equal to 7, then y and z are equal to x and x plus 1. So it goes from left to right. Y gets x, z gets x plus 1. So you, just like you can have multiple assignments, multiple byte definitions, you can have multiple math definitions. So again, for initializing variables, sometimes that's very, very convenient. You can get a whole lot done on one line instead of going through and doing one line per. And I outputted y just for the fun of it. I output z just to show that what that worked. And then we'll output hello world again just to finish up. So let's run this. Go back up to the top. We'll wait for this little thing to stop moving. And we'll come down and take a look at our output. So there's our B as a character and as a decimal equivalent of the B. There's our C as a character. There's our example string. Then we did str4, which was the 5th character of example P. There's our large number integer. And then there is it as a hexadecimal integer. Those should be equal. Yeah, that's about 2 billion. That looks like about 2 billion to me. Then 7 and 8, remember, it was x and x plus 1, and there's hello world. So this should give you an ability that once you get an answer, you can output it to this little output field to see if you got what you wanted. Again, programs are pretty not very interesting if they never output anything because you couldn't see them working. So all these little features are useful for programming because they help you output your stuff to the world so you can see it and so you can debug your programs. So let's get rid of this. Okay, so we're going to write 3 processes. We're going to have send it, which sends some stuff over to the other process, get it, then get it sends some of it back to send it, some of it just sends it to the screen. So we're going to look at some actual message passing here. Now, this particular process send it has a sequential protocol. The channel definition is called a protocol. It's an integer, two colons, followed by a variable length byte message. And the name of the channel is called comms1, communications 1. So again, there's a lot going on here. There's the word process, process name. We're going to define the channel. It's a sequential channel definition or protocol where we have an integer which defines the length of the message, colon, and then the bytes that make up the message. So you can see that messages can be, have much more sophisticated protocols than just a simple byte. So we'll define a 256 byte vector called stringy. I didn't want to use the word string, so you might think it was some kind of reserved word. It's not. Then a bunch of integers. Again, you'll notice the indenting here. We have a process, we indent in 2. We have a sequence, we indent in 2. It means all these instructions work sequentially. Comms1, bang, and then we're going to output 21 values. And that's message in a bottle and carriage return. I think the 21 doesn't include the number 21, but you'll figure it out. Here we're going to send out a string. Again, we're going to bang out another one. And this is kind of an interesting syntax. It's the string variable from 0 for A. So it's starting at 0, going for 11 characters, and that's variation. The 11 doesn't include the number. And then we're going to, actually, that's just putting that in the string. Then we're going to output the string from 0 for A. A was 11. So here was one way to send a message as a literal. Here's one way to send a message that's contained in a string. And then we're going to see yet another kind of even more flexible way. We had some hardwired numbers in here. Let's make all of these variables. So if we had all of our messages in one string, we could have a starting byte, an ending byte, a length of message, and all that. So we're going to have A equals 13, which is the length of our message. B equals 1. We're going to start from the first character, not from 0, but from 1. So string E from B, 1, for A, 13, hello world. Then when we go to output this, we're going to do D, which is A plus B minus C, or 14 minus 2 is 12. So we're going to output 12 characters starting from the second character. Remember, we put the string in starting from the first one. So we're going to drop the H in hello, hopefully, and we'll send that out. We're going to comms1 bang that whole thing. Now, a little thing about math here, Occam doesn't really use that really sophisticated precedent stuff that most languages uses. Their recommendation is just put parentheses everywhere you want them to be, and that's how we'll figure it out. If I took these parentheses out, the program would actually generate an error. So remember, when you're doing math, even if it seems very, very simple, that addition and subtraction always have the same precedence. Put your parentheses in, and that way the program is absolutely sure it knows what you're trying to do. Now that was, again, just one program which is sending things out to the other program. Let's look at the get it side of the program. We're going to come down here, get a string. We're going to get 3 messages. Remember, we sent 3 messages. So here we say comms1 gets a length and then a string. Again, we use string E, but this is in a different process. And now we're just going to output it to the screen. For j equals 0 for length, out string E of j. So we're just, whatever the length is, we're just going to output it. So this will go through and grab 3 messages and output it. So this is very simple. But before we do that, we've defined 2 processes, but we really haven't told them how they're tied together. So we have a third process, which defines how these 2 processes are related. We're going to have an overall process called sendGet. It's a channel. The only thing that this process, the highest level, uses out. We'll see in a second where comms1 came from. But we have this channel internally, which is going to be used between the processes. Again, it's the sequential protocol, integer followed by a whole bunch of bytes. And here's again another great Occam word. It's parallel, which means these processes are not sequential. They're running in parallel. Send it and get it. You could have them on 2 different transputers, and the only thing they know is what goes down the links between them. And this is kind of the whole power of the transputer, is you write your programs so that they can be spread across as many transputers as possible. And so this is kind of the preferred way of doing multiple processes. There are other ways you can do it. I did in Hello World, I did it slightly differently, but I would copy this style of process. So let's run it and see what happens. So there's our message in a bottle variation and Hello World without the H. So let's go up and look at that again. There's message in a bottle variation and Hello World, but we started sending it from C, which is position 2, so we only got hello world. So that's, again, we did some output stuff that helps you debug your programs and see what's going on. And then we actually did 2 processes and then kind of the controlling process that shows how it works and what the, very importantly, tells you what the communication paths are. When you're doing this process, it's almost all about defining the channels very, very clearly.